Good day, everyone. I'm talking on a smart dustbin using Arduino microcontroller this time. Uh, Dustbin. A dustbin is a container for the collection of waste. The main aim of this project is to design a smart dustbin to keep our environment clean and eco-friendly. As we know that we generate waste both indoor and outdoor every day. So we need to keep our environment clean, maybe in our homes, in the office, outside the home, along the street, and everything is getting smarter by day. So we don't need to stress ourselves too much, and that's why I am introducing this one to us also. Human beings are getting smarter by day as technologies are advanced. So we don't need to touch everything in our homes, offices before they are activated. Yeah, we need to be smart also in our daily activities. In this project, a microcontroller having an ultrasonic sensor with a servo motor is used for the smart dustbin. In the last project, I talked briefly on Arduino. And here also, I will show an Arduino board that I use. So after all the hardware and software are connected, the dustbin lid will open automatically with the help of the sensor and the motor. And the motor when someone comes closer, that is in close proximity. When you move closer to it, then automatically the dustbin, that is the smart dustbin, will open up and closes afterwards. Though this is calculated based on distance because the ultrasonic sensor works with distance. So this is the Arduino, one of the components used for the project. The Arduino is an open source platform used for building electronic projects. One of the basic characteristics of fusion of this Arduino board is, for instance, I'm using it for a smart dustbin now. A program is compiled on it. I can use it for another thing again. So that's why it's called an open source platform and it's very durable. It's not that after using it for smart dustbin, I can use it for any other thing. I can write another program on it. So Arduino consists of both a physical programmable board, often referred to as a microcontroller, and a piece of software or IDE, integrated development environment. And that's the environment we write our sketch in, just as I showed to us in my last video. So it runs on your computer, used to write and upload computer code to the physical board. Arduino UNO is a microcontroller, but it has 14 digital input or output pins. If you look at it, it's starting from 0, 1, 2 to 13. Those are the 14 digital pins, and I made it clearly the last time that it's having some like pin 3, 5, 6, 9, 10, and 11 are PWM pins. It 6 analog input. You see it A0, A1, A2, A3, A4, A5, and it's having some power inputs too. You have 5 volts, you have the ground, and you have the 3.3 volts input. This is the ultrasonic sensor. You have the VCC that is connected with the power supply. You have the trigger pin, you have the echo pin, you have the ground pin. The ultrasonic sensor, the HC-SR04, that's the model, uses sonar to determine the distance of an object, just like the bars do. It offers excellent non-contact range detection from 2 cm to 400 cm. Ultrasonic sensor module has 2 drums. Looking at the picture, you can see the transmitter and the receiver. You can see it's written T and R, and this is regarded as the transmitter and the receiver is regarded as, it looks like drum actually. So that's why I said one of the drums is used for transmitting the pulse of an ultrasonic sensor, and the second drum is used for receiving the ultrasonic signal. And if you see ultrasonic sensor too, they have 2 main components, that is the transmitter and the receiver. And these ultrasonic sensors too, they are used basically for proximity sensor, that is, it sense how close a person is to it, and they are used for in automobiles for self-parking technology, and they are used for in robotics for obstacle detection. Yeah, when they use them in robotics for obstacle detection, that is, when it's going to maybe towards a wall, it will sense it, you understand, calculate the distance, and sometimes automatically the vehicle will stop. So it has so numerous applications. Then this is the servo motor, this small servo motor we have, and this is the cable. The cable are usually three. Yeah, it comes in three colors: one brown, red, and one orange color. You can see it. The red is connected to the positive supply, then the brown is connected to the ground, then the orange is the PWA, that is connected to one of the digital pin. And the servo motor is a small device that has an output shaft and can rotate between 0 to 180 degrees, but it's advisable not to turn it to 180 degrees. You understand? For safety purposes and for the longevity of the servo motor. I think you understand. So you can vary it maybe between 10 and 160 for a good option. And this is the project circuit diagram. I did this one in Tinkercad. You can see it. This is the power, so you can see the power button. That you can see this reset button in red. The black down one is the power input. You can use the maybe your battery. Like this one, I use battery to power it. You can use your battery, and then you can power it through your laptop too when you're programming it, because you virtually basically the USB of a laptop generates 5 volts, so it can still drive it. So you can see the power I connected, the power red 5 volts. You can see the servo motor, and you can see the ultrasonic sensor. So this is the basic diagram of the. Then this is the Arduino code. Yeah, like I said in the other video I did about a week now, you need to include some library, and this is the library. Includes servo motor, then the trigger pin is connected to pin 5, the Arduino echo pin is connected to the pin 6, and you just have to write your code. Then calculating the distance, because when you move closer, it depends on the distance you calculated, so you can change the distance, and you can see the distance here, 0.034 times duration over 2, and the distance normally is calculated as d is equal to half tc, and the t there is, though this one is not stated there, but the t is the time, and they say the speed of sound, and the speed of sound is like 343 meter per second. So the code, you can copy the code and write it in your IDE and load it on the Arduino for testing purpose. And this is the making of the Smart-Dustbin. Yeah, from cutting the cardboard, then fixing the components.
This is just a short clip on how to make a smart dustbin. So you can just take a small bucket and maybe a cardboard just for the cover, and get a small circle just like this. You can see I've traced out the circle, and it's a perfect cover for the bucket, and you can divide the circle into maybe 2 equal parts, or make the opening very large than the back, you can see. So now the next stage now is to fit in my ultrasonic sensor in front of the bucket, and to fix the servo motor and the components. Stay tuned. This is the ultrasonic sensor that is used for measuring distance. So it will be placed in front of the dustbin just to measure the closeness of the person who wants to drop any dirt into the dustbin. You can see I have traced out the point at which I will fix my ultrasonic sensor. Now I'm going to make a hole in the two places. Now the sensor, the ultrasonic sensor, is perfectly fixed into the bucket. Now I have to use my glue gun just for a small part, so that it should be stable on it, as you can see. Ooh. Okay, I think this is perfect. I have fixed the ultrasonic sensor in front of the bucket that I use as the waste bin. You can see it. This is the ultrasonic sensor, and this is the servo motor. You can see I attach a small tiny rod, and let me say weightless rod, yes, very tiny one, on top of the servo motor, so that it can help in opening the lid up. Then this is the Arduino board, Arduino UNO I use. I just place it. I know it's not a permanent something. It's just for the practical purpose of it and for illustration. So that's why I'm putting it on the lid. Then this is the battery, the 9-volt battery I used to power it. This is the power supply port, and this is the program port that I use. I can power the waste bin too from my laptop. This is the USB, and this is the cable we use in programming it. You understand? So after this, then let me power it up for you to see. You can see automatically it came up, and you see it. Then when it senses, look, the bucket will open up. Then after some seconds, I give a delay of like two seconds. Then when it senses, it will just open up. Can you see that? So let me just try. Can you see that? Let me just try and again. Can you see that? Can you see? I just want to try to walk towards it. Maybe it will open up anytime. Can you see? It opens up. I want to drop another thing. Can you see? Moving closer to it, and it opens up. So the smart bin is working perfectly. You know, this thing is using battery, so sometimes the battery may not supply a good amount of current because of the constant usage, and that's why it's advisable for you to use a good battery that can supply a good number or amount of current for a longer time, so that your battery does not drain often. That's what I want to say. So thank you very much, and thank you for listening. I believe you can practice this at home too, and you get the components. Thank you.
Thank you.